Imagine you are generating many transactions in your verification environment. Sometimes you want one rule to apply to every object, and sometimes you want all generated value to be different so that your test becomes stronger. SystemVerilog gives us two very powerful constraints for this: a static constraint and unique constraint. Let's understand how verification engineer actually use them. Static constraint. Normally, when we write constraint in a class, they apply to that particular object. But sometime in verification, we want one common rule shared across all objects of the class. That is where static constraint comes in. Let me show you the idea. Suppose we have a packet class, and inside that class we have a random variable called data. Now we add a constraint saying that data should always be less than 10, but this time we declare the constraint as static. What does that mean? It means this rule is not tied to just one object. Instead, this rule becomes common for the entire class. So now imagine we create three objects of this packet class: packet 1, packet 2, packet 3. Even though these are different objects, all of them must follow the same rule. The value of data must always stay below 10. Verification engineers use this when they want global restriction like limiting address range, packet sizes, or protocol limits across all transactions. Instead of repeating the same constraint again and again, one static constraint control everything. Cleaner test bench, less chance of mistake. Now unique constraint. Now let's move to another very useful concept, unique constraint. In many verification scenario, we want all generated value to be different. For example, transaction ID should not repeat. Addresses used in test should be different. Packet number should be unique. Without system Verilog support, we would need to manually compare values and remove duplicates, which become messy. Instead, System Verilog gives us a very elegant solution. We simply tell the constraint solver that the variable A, B, and C must be unique. When randomization happens, the solver automatically guarantees that no two variables will have the same value. So if A get 5, then B and C cannot be 5. This ensures better randomness and also helps us avoid hidden bugs caused by duplicate values. That's why verification engineers often use unique constraint in transaction generation and address testing. So remember the key idea. Static constraint means one rule shared by all objects of a class. Unique constraint means all selected variables must have different values. Small feature but extremely powerful when building real verification environment. And here's at Logic Verify, we don't just learn syntax, we understand why verification engineers use it. This is Logic Verify signing off.